Hello, everyone. In this lesson, we will learn about the second part of the paste box process, the structure of the folder gluer. Firstly, let's examine the basic composition of a common folder gluer. It mainly includes the feeding part, pre-folding part, hook bottom, gluing part, folding part, pressing part, receiving part, and so on, as shown in the picture above. Now let's take a detailed look at the role and composition of each part. The first is the feeding part. The main function of this section is to separate printed materials one by one. It is mainly composed of the paper belt, main front gauge, auxiliary front gauge, side baffle, and rear baffle. The paper belt's primary function is to transport the paper box, to improve friction between the box and conveyor belt. A suction, vacuum, conveyor belt is generally used as shown in figure above. The main purpose of the front gauge is to position carton fronts accurately. The height should be adjusted according to cardboard thickness, to ensure smooth passage without gaps. Positioning follows four principles. First, as close as possible between first and third creases. Second, as close as possible to middle of cardboard. Third, placed opposite longest cardboard edge. Fourth, placed opposite widest front cardboard edge. The sub-front gauge serves to securely hold the paper pile in place, preventing it from falling due to gaps between the side baffles. Typically, the height of the sub-front gauge is 3 times the thickness of the cardboard. The role of the side baffle is to position the side of the cardboard, while maintaining a 1 to 2 millimeters gap and avoiding direct contact with the cardboard. The primary function of the conveyor belt press wheel is to align the cardboard against the side plate, ensuring proper positioning. The rear board tilts the pile slightly to facilitate separation. The second part involves pre-folding, which utilizes die-cutting indentation lines to bend carton sheets at 120-degree or 150-degree angles, with different angles required for specific creases such as those found on first and third crease lines. This process is completed using a combination of belts and guide rods. For some special creases, different angle tools are also needed to complete them. Usually, pre-folding is carried out at the first and third crease lines of the paper box. The upper left diagram illustrates carton creases, while in middle left depicts product pre-folding process. Finally, lower left shows pre-folding rod. The third part pertains to the bottom of the hook, which involves the use of a hook that can swing up and down to latch onto the bottom corner of the box. The bottom of the box is then subjected to forward and upward tension, causing it to bend along the indentation line. As a result, the bottom of the box bends, allowing for the hook to come out of the box. If the box completely passes through the hook, gravity causes it to fall, thus initiating latching onto the next product at its bottom. The left picture illustrates this process, while on right depicts an example of carton's bottom. The fourth part concerns gluing. This step involves bonding parts of cartons using either a glue tray or a glue spraying device. Currently available gluing devices include those with a glue tray and those with a glue gun. A typical gluing device consists of components such as a gluing pan, gluing wheel, press wheel, and gluing regulator. The rubber wheel rotates to extract adhesive from pot before applying it onto cardboard welt in tape form. The left picture shows schematic diagram for glue device on tray, while right one displays physical image. The glue gun gluing device is composed of parts such as a glue spraying gun, controller, valve, liquid pump, conduit, and glue distributor. During the glue spraying process, the liquid pump extracts glue from the glue barrel, which enters the glue spraying gun through the conduit and valve. The glue is then sprayed onto the surface of the cardboard under the control of the controller. The left diagram shows the schematic of the glue gun gluing device, and the right diagram shows the physical image of the device. The fifth part involves the folding process, which is achieved through the upper and lower transmission belts, and the second and fourth crease lines on the carton sheet. This completes the closing of the carton, allowing the adhesive flap to be joined with the side of the carton. To complete the preliminary bonding work, the figure above illustrates the product folding process. The above provides a preview of the product folding, while in the lower left we have a production diagram of this process. Moving on to the sixth part, we have another folding process designed to ensure better collection of paper boxes. This section allows for overlapping of pasted paper boxes, ensuring they are properly squeezed together. Additionally, it reduces conveyor belt speed for improved box pasting results. The top left shows a structure of our folding device, while on top right you can see our production process for product folding. Finally, in our seventh part we have material compaction. Its main function is to prevent cartons from shifting during conveying and causing dislocation in their paste. In later conveying processes, it presses down until all paste parts are dry. The picture above demonstrates our production process for material compaction. That concludes this lesson. Thank you for your participation.